Good morning and hello, everyone. Welcome to our webinar on digitalization and the future of heat treatment. I'm Paul Gofas, your host for today's discussion. Thank you for joining us. Digitalization has emerged as a pivotal driver across many industries and is transforming the way businesses operate and innovate. Today, we will explore its impact on heat treatment sector, from connectivity to operational efficiency, security challenges, and as a solution for enhancing productivity. Our focus will be on digitalization platforms like QMULUS and how they play a pivotal role in the transformative journey. Joining us today are Mike Loepke, Head of Nitrex Software and Digitalization, and Frank Pietracupa at Nitrex R&D. Together, they bring a wealth of knowledge and experience that is instrumental in shaping Nitrex's digitalization initiatives. Let me introduce them. First off, Mike Loepke. Welcome, Mike.
Thanks, Paul, and thanks everybody else for joining.
Mike is the architect behind Nitrex's digitalization efforts. He and his team have been instrumental in the creation and launch of QMULUS, Nitrex's pioneer IIoT platform, aimed at driving innovation and efficiency in heat treatment operations. He brings a deep understanding of software development and technological integration to the table. Next is Frank Pietracupa. Welcome, Frank.
Thank you.
As a lead engineer, Frank brings more of a hands-on approach to driving advancements in our IoT integrated products. Frank is deeply engaged at the forefront with customers, addressing their issues and challenges. This close interaction with customers ensures that QMULUS meets their practical needs and effectively addresses real-world challenges. The synergy between Mike's architectural vision and Frank's frontline insights is what drives the success of QMULUS in revolutionizing heat treatment operations. Before we begin, I want to encourage all participants to engage with us by posting their questions in the Q&A box. We will address all questions at the end of our discussion. We'll do our best to answer them all, and if we can't get to yours, rest assured we will follow up afterwards. Today's agenda will cover the following items: the basics, an overview of QMULUS, benefits, data security, and of course, your questions. Gentlemen, let's dive into our discussion. Let's start with Mike and this question. Mike, can you briefly explain what digitalization means in the context of heat treatment operations?
Yeah, thanks, Paul. For sure, I can do that. In general, the heat treatment industry is not really different from other industries. So we are facing the same challenges, the same obstacles, but heat treatment is a bit more conservative. So we are a bit behind, I would say. Other industries are way further. This starts already at the lowest level. We talk about, for example, paperless offices. Yeah, so this is one thing we need to address. So to digitize all the information we currently find on paper, hand drawings, all these things, we need to digitize them. You might think that this is pretty easy. You can achieve that pretty easily, but this is exactly the most, let's say, challenging part of the digitalization. Yeah, most people are bound to their habits. They cannot change it. They are used to have their drawings with them, the paper and so on. So it's really hard to drive people to change their manners. Next step for sure is the connectivity and the integration of machines in terms of data and data acquisition. This is definitely clear that this is required, and for most our plants and almost all our customers, this is already the case. We have all our SCADA systems, we have MES systems, also manufacturer execution systems, gathering all the information. So this is something which is more likely to meet at customers or at heat treaters. Yeah, we see all the machine data and the process data inside. We can open the doors for predictive maintenance, the remote control, and all these stuff, all the keywords you might already have heard of. Next thing, which is our overall goal, is predictive quality. In the end, nobody is, let's say, is driving digitalization because he likes to do that. In the end, we would like to earn some money, and this is all about the quality of our products, which we are producing. And last but not least, I would like to mention that digital product twins is something which is already demanded by the industries. If you talk about automotive industry or aerospace, for example, a lot of the OEMs are already asking for certain KPI. For example, I put it here as a CO2 footprint, are always of interest. And having all these data already digitized in a handover-friendly manner will make our life way easier. And I think that's really briefly what heat treatment is, or digitalization in heat treatment is all about. And there's way more. Yeah, but you asked me to do it briefly, so maybe we switch here to the next question.
Thanks, Mike. Frank, this question is for you. And as a seasoned engineer in the field, what do you think drives digitalization in heat treatment? And can you provide some examples?
Yes, Paul, thank you. Well, I think first off, I feel that the end user is expecting a lot more than in the past. Where are my parts? They need to know where are my parts. I want to know where they are. I want my charts. Where are my TUS? I want to see when the last time you did it. What were the results of the parts, of the sample in the parts I sent you back in November? And they want this now. So we got to an age where, like Amazon, I'd like to track my stuff whenever I want to. Immediately, I need to have my information right now, 24/7. Despite this, the end users also want the lowest cost. So you need to keep your expenses down. You can't do any rework. You need to maximize your furnace usage. You need to achieve all the results that are expected and you quoted, but not more than that. Compliance is another one. So following the evolution of norms from CQI 9, NADCAP, AMS, things that were allowed, paper that was allowed in the past, paper chart recorders that were allowed in the past are no longer allowed now. So you need to do it, okay? If you are buying old equipment, your old equipment comes with some controls, some sort of control panel, which you can update it. You can, spend a lot of money to make it fit in properly, or you can do as little as possible to integrate it. Now, what happens? Your people have to get used to something that is completely different. And this is a challenge. So it's nice if you could combine everything into one, and your operators are getting used to the same interface, the same interaction. Knowledge of transfer, succession, personnel. Okay, personnel is a big deal. People that know furnaces, heat treaters is it's an art, it's a science, and having one guru who knows everything in one plant, that's great. If you have a multiple plant, you need 4 gurus. No, good luck with that. So if you have that global view, this one guru could oversee all of these furnaces and have be more useful to everybody. Accountability. You need to know who changed that recipe, when was it changed, why was it changed, traceability, what work orders went out. So if we made a change back in, I don't know, November, and oops, someone forgot to click on enable a dissociator, enable a pump, enable an analyzer. We found the mistake right after Christmas in January. Well, what work orders ran through the shop that touched, I don't know, furnaces 3, 5, and 12, that included 4140? QMULUS can answer that question. So this is where QMULUS is strong.
Thanks, Frank. Now, here's a question to both of our speakers. For those who may not be familiar, could you provide a simplified explanation of cloud-based platforms like QMULUS and how they benefit industrial settings?
Yeah, sure. So I would like to start on this here, since this is always the most important thing when I talk about digitalization. It's all about data. In the end, everybody thinks, okay, we would like to do machine learning, KI, everybody's talking ChatGPT and all these things. But this is all worthless if you don't have, let's say, a good set of data, a well-architectured data engine below. Otherwise, it's just a mess of information which you cannot use properly. And yeah, you cannot find anything. Yeah, it's exactly if you just go into a room where all these papers are lying on the desk. Yeah, you will not find anything. You cannot learn anything from that. So that's why I always tell people the most important part of an IIoT platform or a cloud solution is this data engine. I just provided here this, let's say, universal structure of how it could look like. And I do not want to go into very details here, but there are a few more really important steps which you have to follow. And the first one is the identification of data. What data would I like to integrate? What data sources? What types of data? And all these things. This is really the first step. So maybe making up your mind what is to be integrated. Second, okay, how do I integrate this data? Yeah, it's always sounds pretty easy. There's an SQL database, there's an CSV file, there's an audio file, there are images. For all these, you need data integrators. And this is also something you have to overthink. Next thing is how would you like to document that? Just putting everything, as I already mentioned, into one big data sink is not beneficial. Yeah, so if you put it there, it's lost. You have to document everything. So that means where does the data come from? If you talk about process data, for example, which unit, timestamps, all these things. You have to think about it and you have to do it carefully and properly. Otherwise, it's just a mess. And that's why it takes a long time. What was that? That's why it takes a long time to create such an infrastructure. Next thing is the data lake. Yeah, all the data will end up here. We are talking about raw data. All the data which comes directly from the data integrators, from the connectors, is put there, but documented, as already mentioned. We have this data dictionary, the semantic we can talk about. Yeah, really raw data. Then we have the data warehouse, which is more ordered, contextual. What is it called? Sorry, I'm struggling with the word. The data is put into some kind of a context. Yeah, in terms of heat treatment, for example, you can decide at the beginning of the data integration if you would like to order everything by loads, by parts, by orders, and so on. And if you do that in a proper manner, you can have a context to read the data and to receive the data. And then there's the last point, is universal API. If the data is there, well structured, described, and then so on, it's still worthless if you cannot reach it, if you cannot access it. And this is exactly what we would like to have. We would like to have data accessible and make things more transparent. Talking, if I could say things, I mean processes, data, whatever you like. So everything needs to be more transparent in the end. And that's why you need this well-architectured data engine as a heart of an IoT platform. And on top of this, you can build all the things which you have in mind. Yeah, you can start doing statistics. You can do remote monitoring in general. You can do KPI tracking. You can do machine learning. You can even use your ChatGPT to answer you some questions on base of your data. This is also possible. Yeah, but without that, no chance. So this is really the heart of it. And as you all can assume, around this let's say heart of our IoT platform, there are multiple things. There are all these applications which you might know from different vendors. We also have in QMULUS, I think, almost 20 of these for different purposes, which are all communicating with the same data source. And yeah, that's it. So maybe, Frank, you would like to elaborate a bit more on how this can be connected to your machines, to the things which you have on premises.
Yes, Mike, yes. I made this slide to maybe bring your slide down to an everyday use, right? So we don't see the little boxes inside. Basically, what I'd like to explain QMULUS is starting from on-prem, you have control panel. This control panel has some controller, it has some PLC, it has some IOs, it has something controlling. This controller comes from various sources, from various eras. You have something from the 80s, which was relay logic, and you could have something that's brand new. We're going to collect, well, we have our drivers that are going to collect, we'll have our methods to collect this data, and we're going to put everything on your computer on your premises. Okay, so we're going to store everything locally. And this acts, first of all, acts as a buffer. And second of all, this is the whole security is within your walls, and it's not going out, and everything is secure on as far as the operational technology. All the controllers are safe. This SQL is now talking to QMULUS, and QMULUS is cloud, whatever, but basically QMULUS is instructed to speak to only one computer, and it's the one in your shop. So we also have that security going on. I mean, according to how the savoir-faire, like how things are done in the know-how, basically QMULUS is speaking to that one computer, and we're basically replicating, causing this mirror. Now QMULUS on the cloud, using the CPU power of Amazon, whatever, is analyzing, massaging the data, is populating all these dashboards. Now, one thing where we work with you, temperature, pressure, carbon, all of that is easy. You take it for granted, okay? Do you have some sort of flow meter? Do I have an electronic flow meter? Then I do. Then I'm gonna grab things like flows, percent power, raw millivolt. Maybe I could read it, or maybe by the time the PLC gets a signal, it's already a carbon potential. So I don't know. But that type of information is very nice to have. But even more data, give me a work order number, give me a recipe number. What is the current step of that particular controller? Go further, the mass per load, the material, the hardness, the K-step, after the sample is evaluated. All of this, if you enter into QMULUS, then QMULUS can now massage the data and make better dashboards and different analysis.
So let's go to the next question.
Next question.
Again, it's for you, Frank. Is QMULUS for everyone in heat treatment, and who can benefit most, and what equipment can be connected?
So the question is very wide, and I'm just choosing a few points here. I decided to just give like down in the shop and up in the corporate side. Okay, so down in the shop from an operator or a new hire. Okay, so in those two people, actually two personas. One person could be extremely knowledgeable, and on the other hand, the person that we hired has absolutely no idea what a heat treat shop looks like. So both we benefit. Okay, so on one hand, an operator, hopefully they know what they're doing, they know they're carburizing, that they know potentials, they know quench intensities, electricity, they even have to know a little bit of power distribution, PID loops, gas flows. Like they're the people that are going to be answering the questions of everyone else, right? So this makes this person extremely valuable and extremely spread thin, and the core of everyone. So now if we give this person the view of the plant as a whole, so now I get to see all of my powers and all of that from afar, I'm less stressed, I'm less interrupted, I'm more in a position to be a mentor to others. I can get a global view and react and predict and plan, as opposed to, okay, something broke, I need to fix it now, and I didn't know it was breaking. So basically, I get a global. QMULUS will give you a global view with the health of the plant. One thing QMULUS also does is it gives you like a time elongated view. I don't know what the right word for this is, but you look at a controller, your C potential is 1.0, and your set point is 1.0 and you got a 1.05, it's good. You walk away. You know it's a 1.0, you look and it's a 0.95, you know it's good, and you walk away. But the thing is that if you look at the average carbon potential example versus set point over the last 2 years, well, okay, 2 years maybe it's a bit too much, but over the last 6 months with this particular probe, I changed it and now I'm drifting. I get to see that. I see time in a broader view where a human tends to see only one spot, you know, like a photograph. Looking at it from big business, okay, now admin can oversee KPIs of multiple locations, notice creep in data. I get to see anomalies. Why is it that, you know, we're doing less amount of pounds or kilograms per month or recipe? Why are you guys always running, for example, you're running always recipes 2 and 14, that takes up 60% of your recipes are 2 and 16. Why? Are we too focused on that one customer? What is the consumption of the gases per month, per equipment, per recipe? I could see all of that information, right? And again, big businesses want to see that, but imagine if you're a new hiree, you were working at a completely different industry, and well, now I can take a look at this, and it gives me some insight. Assuming I'm curious and interested, it gives me some insight into what we used to do, what we should be doing, and where my focus is. Where's my 80-20 rule here, you know? Another thing that just, again, hands-on, your new hiree, you tell him, her, whatever, well, set the oil temperature to whatever, 175. Well, you know what? The oil temperature on the modern furnace, it's on the HMI. On the 20-year-old furnace, it's that separate controller on the top left. And on the old furnace, it's, I love it, that old Park-Low that's on the oil tank. And it's not even electric, it's actually pressure telling me the oil temperature. Well, how is this person supposed to know that? You know, it's all over the place. So QMULUS kinds of makes everything a little more universal. So we'll map everything so it's easier to find and easier to compare. Hope I answered the question. I hope I didn't rant too much.
Let's move on to the next question, and this once again is open to both of you. We'll start with Mike. The question is, what sets QMULUS apart from other available software options?
Yeah, so QMULUS has not been invented from scratch. Nitrex has a long history in providing SCADA systems, MES systems, which were, let's say, more conventional, being on premises installed, but nevertheless famous on the market and well used and developed, I think, over the last 20-30 years. And I think this is something which not too many competitors or other systems can rely on. The most important part here is that in the history of these MES systems, SCADA systems, it was never meant to be used for only one kind of furnace vendor. Yeah, so we are lucky, we can use it for all different kind of furnace suppliers, or for all the furnaces of different suppliers, let's call it like that. So this is one thing which most of our competitors do not have. The next thing is that we are for sure offering the same functionalities as our SCADA and MES software. So this is all included. So you have something which is on top of your SCADA and MES software, which you need anyways. We have this well-architectured data engine. I already mentioned that. And we have some specialists here at Nitrex who are really experienced in doing such things, really doing industry-focused data engines, so that we have really the right manner of, or the data is ordered in the right manner to make really good use of it. For sure, we are offering some enhanced statistics, a about asset health, the whole production performance. And I think Frank already mentioned that. Yeah, so that's clear. We are offering a lot of dashboards and also the option to do self-service dashboarding. So whatever you would like to see, when you log into your platform, you can just create your own dashboards and put everything together, because you have always access, as I already mentioned in the questions before. We have this universal interface and you can use it. All the data available in QMULUS is available for you to use it. On top of that, for sure, we have some specialists in heat treatment and some well-known people on the market who have always great ideas and their own models. We have simulators for different kind of processes, carburizing, nitriding, nitrocarburizing, low pressure carburizing, for example, all these things. We have simulators for that. On top of that, we are making use of machine learning, enhanced statistics to detect automatically anomalies. I think we will mention that later. We will go to in the details here later, which is also pretty unique, I would say, because we are not bound to a specific kind of equipment. We are doing it in a more general way, but yeah, I will explain it later on, I think. Last but not least, most of our competitors are selling their software, which is really down to asset health. So talking about maintenance, predictive maintenance, and so on. This is something which we are also doing. That's clear. But we also focus a lot more now on the processes and the quality. Yeah, because this is something I already mentioned, that what we are yielding at. Yeah, so quality is in the end what we are doing, yeah, or what we would like to achieve. Yeah, so nobody, if we could, yeah, I think all our machines and our equipment could just be as it is, yeah, if the quality would always stay the same, but this is not the case. So that's why we have to take care of the asset health, take care of our processes, enhance the quality, and make sure that we are always in line with that, with our specifications and being compliant. Yeah, I think that's from my side.
Yeah, Mike, if I can add my my 2 cents to this this question, from a different point of view, QMULUS strength is also that, like I said before, we integrate data that is not from different vendors, different generation, and we integrate this into our database. Now, QMULUS, the core of QMULUS is to analyze data. It's going to analyze, compare, try to find patterns. It's whatever, things like percent power, dew point, cooling water flow, consumption of gases. QMULUS does not care what is the unit, the actual value. It has AI and statistics deep in the DNA of the software. Its strength is how it looks at data. So comparing itself with a set point, that's easy, but comparing data to itself from the past. So that's that's part of its strength. Okay, so that I think makes QMULUS unique.
One additional thing which I would like to add here, we are talking always about process data, and QMULUS is not really restricted to process data. We can take whatever data you have inside, and we are not also restricted to manufacturer execution data, the SCADA data, and so on. We can integrate whatever data you have and make it available in this data.
Yeah, it doesn't necessarily have to be temperature.
Exactly. Yeah.
It can be an air compressor.
Yeah, it's also, we can talk about quality data. We can talk about auras. We can talk about everything you like. Yeah, we can put everything there, put it in the context of heat treatment, and analyze it, play with it, and benefit from it. Yeah.
Okay. I'm just going to move to the next question. Mike, this is for you. How does QMULUS improve furnace performance and operational efficiency while streamlining knowledge and automation in heat treatment processes?
Yeah, thanks. I will just go for one story because we have multiple ways to do that. But I think this is one which I already mentioned, which is really unique. Just giving you some background before I start. So heat treatment is I always call it a robust industry. And if I say robust, I mean the processes, I mean the equipment, I mean also the quality. If you talk to the OEMs or the heat treaters themselves, they have rarely some bad quality. At least they will never tell you. Let's call it like that. And this is our problem here. Because if you are in an industry or an environment where everything is always good, it's really hard to do supervised learning. Yeah. So for example, if we do not know that something is broken or it breaks only once a year, it's really hard to get enough data to create machine learning models to do supervised learning. And that's why we changed our minds and we did something other way around. Because the industries and the processes and the equipment is so robust, it's really easy to identify normal behavior. So how a machine should usually behave, how a process should usually run, and what the, let's say, the estimated quality should look like. That said, we are creating, with help of statistics and machine learning patterns and rules, how is this behavior, how this normal state should look like. This is done automatically, continuously, every time. Yeah. So for all the data incoming, everything is analyzed, everything is just putting into these patterns and controlled if it's behaving as the patterns are dictating. Yeah. So if it's something deviating, if something is drifting, and if something is maybe going out of bounds, the system will automatically notify us. So we call it anomaly detection. So you have these observations. And with these observations, it's pretty high. Going, for example, if you talk about control loops. Yeah, if you have, for example, a temperature control loop, out of bounds error or observation, we can directly say which root cause that it could have. And this is exactly why we talk about an FMEA here, because in the end we have a lookup table. Yeah, or your specialist or your specialist at your heat treatment plants know best what in such cases might be wrong, what should be repaired, and so on. And this FMEA has a closed feedback loop. So whatever observations you have, you can put whatever root cause you're estimating or maybe have found. And additionally to that, you can also put some recommended actions. And this is something which you can do over and over again. And I think, yeah, I think this is really beneficial for the heat treatment in the end, because you can put your knowledge of your local maintenance crew into a rule-based system, an expert system, which can then be used. I think Frank mentioned that if you have this new fresh guy, for him to be trained. That's one of the steps. Additionally, a lot of things you will never notice. For example, I think maybe Frank, maybe you would like to share that because you're a bit more familiar with these processes and with the real problems in the heat treatment shop. So maybe you would like to talk about a bit more about
some examples that kind of bring it down to earth.
Yeah, you can skip that next slide. Maybe go to the next, direct to the next one, because the FMEA.
And the next slide is a question.
Yeah, it's a question that we'll go back to Mike's comment.
I just want to point out to everyone that we're at the halfway mark.
Yeah.
We are receiving questions. Keep sending them through the Q&A box. Very good question so far. Thank you for sharing. Frank, this question's for you. Can you discuss the role of machine learning in predicting and preventing potential failures in heat treatment processes and how QMULUS supports this approach?
Okay, I have a couple examples to give you. I'm still going to try to speed it up a bit because I think we're running a little late. But what Mike said was the core, the statistics, and the diagram, the blueprints of what's happening. But I'll give you I want to bring it down to day to day. So going back to our furnace, okay, which again does not need to be a furnace, but it's a furnace. Typically, it's going to heat, it's going to hold, and it's going to cool. So power, in a batch furnace, is going to tend to jump to, let's say, 100%. If we're looking at the graph on the left, on the gray line would be power or power loss or, burner on time, that type of thing. So it goes up to 100%. Once the load gets the temperature, then it backs off, goes to, I don't know, 12, 15, 18%. In this case, it says power loss equals 12 kilowatts, right? In the graph, the gray line in the graph. But fundamentally, it goes up, hard, backs off, holds, 0. Hard, hold, 0. This becomes a pattern. Okay. Now, of course, if I have a full load, I might be at 18, 20% holding power. If I'm a very light load, a couple of samples, minimum load, I'm going to be down to 10% power. Now, assuming that you have multiple zones, a zone breaks, the heater breaks, the gas is turned off on that one, whatever, a fuse blows. At this point, the power for that zone is going to be, let's say, 100% all the time because it's too cold relative to its thermocouple. But it also, the other zones will catch up. So unless you have a monitoring of the fuse or monitoring of amps or something, you probably wouldn't notice because your parts are coming out. Maybe it heats in 15, 20 minutes longer than it would have. But then again, the difference between 1,000 pounds and 2,000 pounds might go unnoticed. So what this does is QMULUS actually is not predicting. At this point, it's observing the past. And you were always, sometimes at 12%, sometimes at 18%. But then all of a sudden, boom, if we look at the graph on the right, that's kind of what we're saying. So first of all, QMULUS knows what's a holding temperature, not because if temperature equals 978, that's holding. No, it just learns because that's when it settles. And it settles, and you could have a low temperature recipe or a high temperature recipe, and that's a holding pattern. QMULUS knows that that's holding. So it knows holding for the past X amount of years, months, weeks is, if we're looking at the graph on the right, the purple on the left was, let's say, normal. Yes, thank you. Then something happens and whoa, we have all these points way on top. And then we find that we had a blown fuse. Okay, easy. Blown element. We fix it and poof, the problem is solved. Now, that is straight, clear cut. But what if you have some sort of a cooling gate that is not closed as it should be? The air pressure on that cylinder is falling. There's a leak. The pressure is dependent on the amount of consumption you're using on the rest of the plant. Well, that's what I'm trying to show here in this creeping error. So there's like normal, and then kind of like it's creeping towards something which is not good, but QMULUS will detect that. Remember, I mentioned before that humans, they see a photograph, right? So I see my carbon potential was 1.1, it's good enough. 1.08, good enough. 1.05, good enough, or KN of whatever, KN of 4, or whatever. The moral of the story is we see photographs. QMULUS sees trends. So if the trend is going in one direction, that is leading to a failure. And QMULUS detects that where a human won't.
I'll move on.
Thank you. Let's move on. Yes. Skip the next slide.
Okay, sounds good. Again, for you, Frank, what sort of improvements have been observed in operations as a result of implementing QMULUS?
Okay, so time-based recipes. And actually this ties into one of our questions as well. Time-based recipes, KN of 4 for 6 hours, C potential of 0.8 for 8 hours. Till the beginning of time, that's how we did it. And you need to, okay, sometimes. But I'm going to say it like this. Do you remember HT tools? I think a lot of people will, it has enough of a presence that we all know what we're talking about, HT tools. So our company has had this modeling software since the beginning of time. It's embedded in our controllers. It's embedded in our older software, PT9800. And it was also available as standalone, okay? Now, here's my Star Wars plug. Like L337 and the Millennium Falcon, we put that source code into QMULUS. And so QMULUS has it as well. So new feature, new software QMULUS, actually robust, known algorithm. Okay, so gone are the days of knowing soak time and temperatures. You simply tell QMULUS, look, if this is the material, this is the case depth, and the surface carbon. Tell me when you're done. Now, once you do that, now, give me my second slide, one more. So, okay, so now I'm going to explain this. So once you start doing that, you're tuning your furnace. And if you're tuning your furnace, you're basically, you're getting rid of, let's call it fixed flows. Fixed flows, fixed time, fixed temperature is fixed. Everything is the same. But yet, due to, I don't know, the surface condition of your racking, due to too much dissociation, due to infiltration of air, all of a sudden your results are not where they should be. So what I'm trying to explain here is in everyday life, if you're trying to hit, and I didn't convert this to thou, sorry, 3 to 4 millimeters, which was quite deep actually, but who cares what the number is? If I'm trying to reach between minimum, maximum tolerance, I may shoot for 80%, 50 to 80% of the set point, just so that most of or all of my samples, my parts, will meet specification. But if I'm able to increase my CPK, I make my distribution curve tighter. Now, with being tighter, I could take my average set point and bring it closer towards the minimum target. Now all of a sudden I saved furnace time. And I still ensure that all of my results are compliant. Another way of looking at this, all furnaces are equal. Okay, give me the next slide, please, Paul. All right, so here, kind of the same thing, but two identical furnaces. In theory, I run the same recipe, and in theory, I get the same results. Well, I don't. Now, the possibility is one furnace, again, has air infiltration versus another one, so I have to run with different, maybe not carbon potential, but definitely different methanol, nitrogen methanol ratios maybe, or even natural gas flows, or nitriding furnaces because of the racking, because of the material of the furnace or whatever. I have a soft furnace, I have another furnace. If I can bring everything in, then I harmonize my furnaces and now they overlap. If they overlap, now when I run my parts, if I run it in furnace A or I run it in furnace B, I'm going to get always what I expect. Okay, and that's what I'm trying to explain here.
So now this is for Mike. Can you discuss how QMULUS ensures scalability across varied IT infrastructures in heat treatment facilities and addresses data privacy and security challenges, especially with sensitive information stored in the cloud?
Yes, sure. I will also keep it a bit briefer. Then you could always go. Security is always a broad topic, and you can discuss it forever. But let's go for the main key points we have here. So QMULUS is not only a cloud solution. QMULUS is a hybrid solution. We already mentioned that. You have a part on premises, you have a part in the cloud. The cloud can also mean that you have it on site. Yeah, so if you're providing us with the right server architecture with the Kubernetes cluster, because QMULUS is a container-based software, we can run it there as well. Then it would be in the customer's responsibility to make it secure. But nevertheless, if you talk about the cloud environment, we are making good use of the latest standards. So we are using everything what the bigger hyperscalers as Amazon, for example, which we are mainly using, is providing to us. So we are using their database encryption algorithms. For example, we're using their backup strategies. We are using their best practices in terms of security handling and so on. So this is everything what we are relying on. For sure, we also take care that we are updating on a regular base, let's call it like that. For sure, if something is required, we update immediately. And if there are some security issues, some known bugs, some known, what is it called? Security flaws inside of a package which we might use, and we are just replacing that in time. This is clear. So we are doing that as Amazon is doing that as well, for example. Yeah, I think that's is the main reason why we make it safe and secure for everyone. We are also undergoing as a company the ISO 27001 and CMMC certification. So we are making sure that we are where we should be in terms of data security and what compliance is all about these days. For sure, we are reading what's, for example, the Department of Defense of the United States is demanding and preparing for that. So we are on this already, and for sure we take good care of your data. We know that it's sensible, that it's a no-go, that we have data leaks and so on, and this is something we are really taking care of. So this is something which is also, as Frank would say, in the DNA of QMULUS.
Yeah.
Yeah,
So I was gonna
it's
say,
like that.
if I can add, that this whole CMMC is coming to us fast, and it's coming to all of us, not just QMULUS. So it's another one of those AMS modifications that all of a sudden you realize, oh, I was supposed to comply with this. Oops, and that's about to hit us.
Exactly, and just to round this up, I think we are not inventing things from scratch. Yeah, so we are making really use of the things which are state of the art, using common protocols, latest security standards, as for example dictated by the hyperscalers as Google, Microsoft, and Amazon. Yeah, that's it.
Great. Thanks, Mike, and thanks, Frank. This brings us to the end of our discussion. We have
On time.
We have 12
We're
minutes
on
left. We have 12 minutes left for the Q&A, and I'm just going to open up the floor, reading some questions that we received. In what ways does QMULUS contribute to driving high-quality outcomes in heat treatment processes? There's several questions. Keep it short, please. I leave it to Frank or Mike to respond.
High quality outcomes. I don't know what you mean, like in a heat treat, right? So
in heat treatment processes.
Okay, I can improve audits. For example, gone are the days where you export to CSV, make a chart, superimpose two charts on top of each other, see if I pass, fail, I put my soak times, I put my upper limit, lower limit. I can now define an envelope there, I say. I draw a box. I come into the box. If I stay inside the box, or never mind that, I go into the box and I leave the box when I'm supposed to, plus or minus whatever tolerance is, then I'm good. And then it becomes a pass. So it's very easy for an operator or an auditor to see if this passed.
I think this is a very interesting question because it relates to employees, specifically new and skilled employees. The question is, we have issues with recruiting, retaining skilled employees with heat treat expertise. How can QMULUS empower less experienced personnel to operate more effectively?
Oh yeah, I can start maybe. QMULUS is providing some kind of an assistance system as well. Yeah, so we can learn how I already mentioned that how a process should run, what is intended, and what should make sure that the quality is exactly what we would like to achieve. And this assistance system can run during the process. So just think of having some envelopes, for example, around the temperature curve. Yeah. So just telling you, please stay in band. Yeah. You have to stay in band for additional 10 minutes. Otherwise, your core hardness will not be reached, for example. Or if you stay longer, you have different other problems. Yeah. So this is something we are providing already. So it's as I said, I always call it assistance system as you have it in your car. Yeah, just making sure that you stay in your lane. This is one example. Yeah, and maybe Frank, you have some more.
I can definitely relate to what you're saying. The thing about QMULUS is it retains your knowledge, and that's the lacking part, right? Because your skilled employees are, I'm 30 years in this company. I know what you're talking about very well. And getting the knowledge down to the shop floor is the problem. So if QMULUS gives you a hint that there's 33% chance that your cooling gate is open, 33% chance that your blower belt is broken, even though you don't have a sensor there, or whatever, 33% chance of something else, your fan is not turning. Well, at least it gives someone who has no idea what a nitrider looks like, 3 things to look at. That's an example.
This is an interesting question, although you may not have any kind of reports to show. I know that everyone can program and use the software for many different things, but is it possible to see some of the reports or some of what it can track or display? Just interested in reports or interface.
Okay, I guess first of all that we agreed on not, well, we planned on not opening the software. So yes, we can. I don't know how we're gonna go over some reports. I don't know, display them later online. I don't know what to do, but I can see things down to the recipe. How many times did we run recipe 12 in this plant? Between this date and that date, I could see how many work orders that I run. Where did this work order go through the furnace? Which furnaces did it go through? I can see things like pounds or kilograms per furnace, per group of furnaces between this time span. I could see things like a consumption of gas A, gas B, gas C, kilowatts. I could see how my furnaces were producing in the past. I can, let's say, predict how my furnaces are running in the future, but now I'm using my, I'm planning my loads, so which some users don't do that. I go to my QMULUS, I load my furnace, I start. Well, then QMULUS didn't know that you were planning to start, so it couldn't foreseen that the furnace would be busy for the next 6 hours. But if you are planning, then yes, it will. If you tell it that the furnace will be down for maintenance next week, then it will block the furnace for next week. If you didn't tell it that, then it won't. So the past is true, the future depends on how you use QMULUS.
Okay, I think it's one of you chimed in through the chat saying that you can actually go to the QMULUS website and register for a demo. What we'll do at the very end of our meeting and in the coming days is share with you the webinar recording as well as a link to our website so you can get more information. Here's another question. If I am correct, you are working with cloud hosting provider. How do they enhance the security and support of your software?
Yeah, so it's pretty straightforward. Pretty straightforward. We started constructing QMULUS, and this is a long journey, by the way. It's not that we invented it last week and everything's done now. So this has been developed over the last 3 or 4 years. I cannot remember correctly, but so we started really relying on, for example, Amazon Web Services managed services. Yeah, this means, for example, if the message comes in, it will run through the Amazon proprietary message queue and so on. All these things we tried at the beginning, and we learned a lot about that. And we learned about the security standards they, for example, using to do so. But since we are having multiple customers all over the world, we are globally operating, as you know. For example, we have customers in China, we have customers in Europe, we have customers in, for sure, in North America, South America, everywhere. Really everywhere, but not every hyperscaler or cloud provider is available here. So that's why we decided in the end to get rid of proprietary services and install it or develop it as a containerized solution, which makes good use of best practices, which we learned, for example, with the Amazon team of North America, which are, let's say, consultants to us as well. And yeah, so that's a story behind it. Yeah, so as I said, we did not invent it by ourselves. We used all the best practices which you can just learn from the big players in the world. Yeah, so for sure we cannot do it better.
Thanks, Mike. One other question. I'm a previous user of Protherm 9800. We found that its simulation function for carburizing not to match exactly with our actual situation. With QMULUS, sorry, we noticed that QMULUS has machine learning. Does it mean it could learn from our current operation behavior and feedback to the simulation algorithm? Finally, if it could help to make the simulation match the actual situation.
Yeah, for sure. We can. So maybe I can just start here. This is something which cannot be true, to be honest. The Aquamon or simulations are 100% accurate. And I'm just kidding, for sure. Simulations are just they are just simulations. Yeah? They are not exactly reflecting what is in real. So for sure, there might be differences. And you're right, you can really fine tune these things with machine learning. For example, you can learn the failure which you are always having. Yeah. So if there is a common pattern inside and you cannot identify it, what exactly it is, you will learn machine learning for that. And for sure, we have all the information in QMULUS. So if you have, for example, if you have all the information needed to fine tune such a simulation, because that means you need to have all your quality data, for example, so all the hardening, the hardness curves and all these things by hand in QMULUS, we can do that. Yeah, so we can learn what is the failure about, and we can just create a new signal, because QMULUS can also do that. You can put whatever signal you like by hand. You can manually integrate data and manipulate it. When you can just couple it then with a simulation data. So you say a simulator is delivering something like a hardness curve, and you just say, my new signal is not only hardness curve, it's hardness curve plus failure estimation or minus, yeah, whatever. And then you can fine tune it like that. Exactly. Yeah, that is possible.
If I could just add my experience on this.
Sure.
Too. So I don't know how QMULUS is, the DNA of QMULUS. I know the practical side of things. And this particular question, I've troubleshot, and I had Michael Winter as my mentor, guiding me to get the simulation on PT98 many years ago to be more realistic. So yeah, a simulation is a simulation, but you still have to do some homework in getting, let's say, shim tests. And I need to do a shim test at 0.8, at 1.0, 1.1. I need to map my furnace so that I can start with a more accurate simulation. So I don't know how the closed loop is designed inside QMULUS, but you still need to have a furnace that is your baseline has to be good. That's what I'd like to say.
Okay, I'm seeing a lot of questions from participants asking about seeing the software in action. They're also asking if it's subscription-based or what type purchase. I won't go into the detail, but I just want to repeat again that at the end of the webinar, an email will be sent in the next few days with a link to our website, the QMULUS website, where you can sign up for a demo, request a demo. And you'll get more information with regards to how the service works. But we're at the end, and I don't want to drag this any further. So before we close, I just wanted to turn to our speakers for some closing thoughts. I'll start with you, Mike. What advice would you give companies who are considering embarking on a digitalization journey based on Nitrex's experience with QMULUS?
Better start early. Yeah, I think this I would say, because it's a long journey. You can start in small steps, and you can go with really step by step, but you have to start. Otherwise, it is just a big amount of work in front of you, and eventually you will be forced to go that way anyways. Now, this is my opinion here.
And Frank, what are your final thoughts that you would like to share with our audience about the potential of digital transformation in the heat treatment industry?
Okay, well, like I love sensors. I love data. I love it. I got to the point where like wife approved home automation is like going nuts in my house. Okay, And the thing is that once you start getting sensors, you start getting data, and you see links between this and that, and it just balloons from there. Okay, so as an engineer geek, love it. And I would like to say from my experience at home that QMULUS should grow as you grow. I think that QMULUS is not a journey. It is a journey, not a destination. I don't think that you can you set up one furnace and that's it, you're done. You'll realize that more data equals things you couldn't imagine before. You will see things you would never have imagined before.
Great. So we've reached the end of our webinar. I would like to thank you again for joining us today, our participants, as well as our speakers, Mike and Frank, for sharing their time, their valuable insights, and enriching the discussion on AI and heat treatment. Again, we have a lot of questions that went unanswered. We will follow up in the coming days. And it's the end. Thank you once again for your participation, and have yourselves a great rest of the day. Thank you. Take care.
Thank you very much.
Thank you, everyone. Have a good day.
Take care. Bye-bye.
Bye.